Hi everyone, welcome to the next video of Python tutorial series. In this video, we will be discussing about how to implement simple linear regression in Python language. And for that, I have imported matplotlib, scikit-learn and scikit-learn metrics. From scikit-learn, we have imported linear model and data sets. From scikit-learn.metrics, we have imported mean absolute error and mean squared error. For our example, we are going to load the dataset from scikit-learn. There are a few example datasets they are having. From that, we are going to use Boston house prices dataset. The price details of houses present in Boston. They have taken 506 sample houses. The Boston house prices dataset is having 13 feature variables and one target variable. In this 13 feature variables, we just need a single feature variable because we are going to implement simple linear regression. And the 14th is a target, which is nothing but the average price of the homes which are occupied by the same owner in $1,000. It's like if the value is 24, you have to multiply that by 1,000, so you will get $24,000. Let's get into Python language. Even I am new to the dataset, so let's see how I am going to approach this problem. So first of all, we have to load the dataset. Here the datasets library will return as X and Y array. We have Boston X and Boston Y. The Boston X is nothing but the collection of feature variables, and Boston Y is a target variable. So here we have given the parameter return X, Y to true, so that it will give the dataset as X and Y separately. So let us look at Boston X feature variables. So it is having 506 rows and 13 columns. From these 13 attributes, we are going to choose a single attribute for our linear regression. So how to choose a feature variable from a set of features? First, we are going to plot X versus Y. We are going to check for each attribute how the relationship is with the target. I'm going to Here I have given X and Y values. I'm going to choose the color as blue. Show. So the attribute starts from 0 to 12 because we have 13 columns in feature variables. So this is what it looks like for the first column. This is nothing but per capita crime rate by town. So it doesn't look much linear to me. So let's just have the first 100 values for simplicity. So it doesn't look much linear to me. It is more of a curved one. So I'm going to look one by one. I'm going to change the second column. It's not linear. Third, not linear. Fourth, it's also not linear because everything is 0. It's also not linear, right? Yeah, this one is much better. So what is the sixth column in our dataset? This is sixth one is average number of rooms per dwelling. So this makes sense, right? The more the average number of rooms per house, the more will be the price value of the house. So let's choose this for our feature variable. So we have just taken the first 100 data points. So let us store it as X. So yes, we have X and Y. Here X is a feature and Y is a target. So let us split this feature and target as train and test split. For train test split, we can import another function using sklearn.model selection library. So let us split train and test variables. From this we have to specify how much is the test size in percentage. We will be going with 20% as a test size, and we have to choose randomly. So we can specify any random state here. I am going with 1. So let us look at the train and test arrays. 80 rows in train datasets, and the test is having only 20 because we had the 100 samples, out of which 20% is 20. So we got test samples as 20 and the training samples as 80. So let us create a model. So I'm naming the machine learning model as Regression REG. So this is our model. So now we have created our model REG. We are going to train it based on the training dataset we have, X train and Y train. So we are going to fit it X train and Y train. So it is throwing us an error like reshape your data either using array.reshape -1, because our feature variable is only 1, so it is not allowing me. So let us reshape our data. So yes, we have reshaped using a reshape method with -1, and we have stored the same in X train. So let us see after reshape what our training array looks like. So it looks like this. What it did is it has taken a single dimension array and it has converted that into a 2D array using this reshape method. We have to do this because then only the linear regression function will be able to understand. So we just did that. So we have our model REG. For that, let us see what are the coefficients. This coefficient is nothing but the slope of our linear regression line. So, and also we can see the intercept using intercept method. So this intercept is having -40. So this is what our regression line is having slope and intercept values. Using this, we are going to plot a regression line among our scatter plot. So let us copy it. We have train and test arrays. Now I'm going to plot a line. So I'm going to use plot function. So what is the line formula? Line formula is nothing but coefficient multiplied by x plus intercept. So I'm going to apply that, multiplied by coefficient plus intercept. Yes, using the line formula we have plotted our line. It is also blue, so let us give a different color. So red. Yeah, now we have our regression line for our training data. So this is how our model looks like. Using this model we are going to predict the test array, so that we can evaluate how our model works. So that is nothing but that predict model.predict, predict it for the testing data. Yes, we have to reshape it as well. So let me do that. So we have this prediction. I'm storing it as y predict. So this is our prediction, and there will be a difference between our prediction and what the data originally is in y test. So that is called as error. So let us find out how our model performs using metrics functions provided by scikit-learn. Green, white test, and our prediction. So this is the mean absolute error, and let us find the mean squared error. So mean squared error is 11, and if you want to find root mean squared error, so you can mention squared parameter as false. So it will give us the root mean squared error is 3.4. So this is how you evaluate your model. So let us look at our results visually so that you will understand it better. I'm going to plot two scatter plots. One is with test and another one with our predicted data, y test and y predict. So for y predict, I'm going to use the color green. The blue colors are the actual data, but the green colors are which we have predicted. So this is the difference between actual data and our predicted data. So predicted data always lies on the regression line, and if you see for the value of 5.8 as x, we have the value of somewhere around 17 as y value, but the actual value is lesser than 15. So this is how it works. So based on this, we have calculated errors here. So yeah, this is how the linear model works. It is not always perfect, but it will give you some idea of what will be the future value based on the historical data. Yeah, that's it for today, and in the next video we will be discussing about multiple linear regression, and we will be implementing one multiple linear regression model in Python. So until then, see you, have a great day.